This is an audio-visual presentation on logarithm. This is an audio-visual presentation on logarithm. Now, according to the definition of logarithm, if you have log of a number to a given base equals another number, from the definition of logarithm, the base, that is a in this case, raised to the power c is equal to the number b. That is from the definition of logarithm. If you want to do away with the log, a raised to the power, that is the base raised to the power c, is equal to b. And therefore, the log is nowhere to be found. So from the definition of logarithm, giving log b to the base a equals c, a raised to the power c is equal to b. Now, let's look at the laws of logarithm. Law number 1, log b to the base a plus log c to the base a equals log bc to the base a. Now, when you look at the first law, we can see that the logs are of the same basis, that is base a, but the numbers are different. They can either be the same or different numbers. Now, our concentration is on the base, provided the bases are the same. Provided the bases are the same, according to the first law of logarithm, keep one of the bases constant and multiply the numbers, and the numbers are b and c. So when you multiply b by c, the result is bc. This means that log b to the base a plus log c to the base a is equal to log bc to the base a. We are multiplying the numbers because we have two logs of the same base adding. That is addition. Take note of the addition sign. It's important. Now, this means that in another way, we can also say that giving log bc to the base a, we can also split it, as can be seen on the left hand side. That is, if you are giving log bc to the base a, because the number bc is multiplying, we can split it by saying that this is equal to log b to the base a plus log c to the base a. It is addition sign because the numbers are multiplying. Take note, we only add when the numbers are multiplying. That is why when the logs were adding, we had to multiply the numbers. Take note of this. Now, example, log 3 to the base 10 plus log 2 to the base 10 is equal to log 3 times 2 to the base 10. Because the logs are of the same base and they are adding, we keep one of the base constant and we multiply the numbers. So we multiply 3 by 2, and that is how come we have 3 times 2. Now 3 times 2 equals 6. So this is equal to log 6 to the base 10, and log 6 to the base 10 is equal to 0.7782. Now law number 2, log b to the base a minus log c to the base a. Now this is subtraction, is no more addition. With law number 2, if you have two logs of the same basis subtracting, when you keep one of the logs to the base constant, you divide the numbers. You will divide the numbers, and that is how come we have divided b plus c. So log b to the base a minus log c to the base a equals log a, that is log b over c to the base a. So you divide the numbers b by c. Now let's take a look at this example. Log 20 to the base 10 minus log 4 to the base 10 is equal to log 20 divided by 4 to the base 10. We are dividing the numbers 20 and 4. That is, we are dividing 20 by 4 because the logs are of the same basis and the base is 10 and they are subtracting, and that's why we are dividing. So when we keep one of the base constants, log 10, then we divide the numbers, that is 20 by 4. And when you divide 20 by 4, the result is 5. So this is equal to log 5 to the base 10, and log 5 to the base 10 equals 0.6989. Now, let's consider the third law. Log b exponent c to the base a is equal to c log b to the base a. That if you have log of a number raised to an exponent, the exponent can take its position before the logarithm, and that is why instead of c being an exponent of b, it is now multiplying log b to the base a. So according to the third law, log b to the exponent c, that is log b raised to the power c to an exponent. The base of the log is a. So log b exponent c is the same as c log b to the base a. The base of the log remains the same. but the exponent now take its position before the logarithm. So log b exponent c to the base a is equal to c log b to the base a. Now what do you mean by that? If you have log 3 squared to the base 10, the exponent of the number 3 is 2, and according to the third law, 2 can take its position before the logarithm, and so log 3 squared to the base 10 is equal to 2 log 3 to the base 10, and this is equal to 2 times 0.4771, because log 3 to the base 10 equals 0.4771, and when you multiply 2 by 0.4771, the result is 0.9542. The result is 0.9542. Now let's look at this problem. If log 3 to the base 10 equals 0.4771 and log 5 to the base 10 equals 0.6990, find log 15 to the base 10, log 9 to the base 10, log 25 to the base 10. Now we look at the solution. A. We were given log 15 to the base 10. Take note, what we have to do is to express this number now in another form. Expressing 15 in another form, 15 can be expressed as 3 times 5, because when you multiply 3 by 5, it's still 15. And so log 15 to the base 10 is equal to log 3 times 5 to the base 10. Now we can see that the numbers are multiplying. If the numbers are multiplying, if you want to split the logarithm, because they are multiplying, we have to split it. We have log 3 to the base 10 plus log 5 to the base 10. Why is it plus? It is plus between the logarithms because the numbers are multiplying according to the first law. So we have log 3 to the base 10 plus log 5 to the base 10. Now log 3 to the base 10 from the question has been given to be 0.4771. And so we have 0.4771. And log 5 to the base 10 has been given to be 0.6990. And so we have 0.6990. Now 0.4771 plus 0.6990 is equal to 1.1761. Is equal to 1.1761. This means that log 15 to the base 10 is equal to 1.1761. Now let's look at the solution in B. Log 9 to the base 10 can be expressed as log 3 squared to the base 10 because 9 can be expressed as 3 squared. Now according to the third law of logarithm, the exponent 2 can take its position before the logarithm. And so we have 2 log 3 to the base 10. We have 2 log 3 to the base 10. Now log 3 to the base 10 from the question has been given to be 0.4771. And when you multiply 2 by 0.4771, is equal to 0.9542. Now let's look at C. Log 25 to the base 10 can be expressed as log 5 times 5 to the base 10. Now if you want to split it, the numbers are multiplying, and so you have to have addition between the two logs. Now we have log 5 to the base 10 plus log 5 to the base 10. When we split, the sign, operation sign is plus because the numbers are multiplying. 5 times 5. Take note that 5 times 5 equals 25. So we are not changing anything. We are only applying the law. And that is how come we have log 5 to the base 10 plus log 5 to the base 10. Now from the question, we were given log 5 to be 0.6990. And so we have 0.6990 plus 0.6990 since they are the same. And this is equal to 1.389. This is equal to 1.389. Now let's look at the properties of logarithm. Log x to the base x equals 1. That is log of a number to the same base equals 1. So if you have log 10 to the base 10, because the number 10 is equal to the base, the answer is 1. So log of a number to the same base is equal to 1. Take note. Then log 1 to any base equals to 0. That is log of 1 to any base is equal to 0. So log 1 to base 10 is equal to 0. Now note, The logarithm to any base of a negative number does not exist. The logarithm to any base of a negative number does not exist. Example, log -1 to the base a does not exist because the number is negative. So the logarithm to any base of a negative number does not exist. Take note. Now, given that log 5 to the base 10 equals 0.699 and log 2 to the base 10 equals 0.301, evaluate the following: log 8 to the base 10 plus log 10 to the base 10. Evaluate the following: log 8 to the base 10 plus log 10 to the base 10. Log 40 to the base 10 plus log 4 to the base 10. Log 1000 to the base 10 minus log 20 to the base 10. Now let's see how best we can solve this problem. Solution. From the question, we were given log 5 to the base 10 to be 0.699. And we were also given log 2 to the base 10 to be equal to 0.301. Now we are asked to evaluate log 8 plus log 10. Take note, they are all to the base 10. 8 can be expressed as 2 raised to the power 3. Log 10 to the base 10. From the property, log of a number to the same base equals 1. That means that log 10 to the base 10 equals 1. So we have log 2 raised to the power 3 to the base 10. Now according to the third law, the exponent 3 can take its position before the logarithm. And that is how come we have 3 log 2 to the base 10 plus 1. From the question, we are given log 2. That is log 2 to the base 10 from the question to be 0.301. And so by substitution, instead of 3 times log 2 to the base 10, we have 3 times 0.301 plus 1. When we multiply 3 by 0.301, the result is 0.901. So plus 1 will now give us 1.903. So we have 0.903 plus 1. And the answer is 1.903. Now log 40 to the base 10 plus log 4 to the base 10. 40 can be expressed as 10 times 4. And 4 can be expressed as 2 squared. Now 10 is multiplying 4. So according to the first law, if you want to split the log, we have log 10 to the base 10 plus log 4 also to the base 10. And according to the third law, the exponent 2 can take its position before the logarithm. The exponent 2 can take its position before the logarithm. So we have 2 log 2 to the base 10. Now log 10 to the base 10 is 1 according to the property. Plus 4 can also be expressed as 2 squared. Plus 2 log 2 to the base 10. Now 2 can also take its position before the logarithm. That is 2 can take its position before the logarithm. So we have 1 plus 2 log 2 to the base 10 plus 2 log 2 to the base 10. Now from the question, log 2 has been given to be 0.301. So by substitution, we have 1 plus 2 times 0.301 plus 2 times 0.301. And when you multiply 2 by 0.301, you have 0.602. And the same thing happens here. So we have 1 plus 0.602 plus 0.602. And the answer is 2.204. This means that log 40 to the base 10 plus log 4 to the base 10 is equal to 2.204. Now C, log 1000 to the base 10 minus log 20 to the base 10. This is equal to 1000 can be expressed as 10 raised to the power 3. And 20 can be expressed as 10 times 2. Now, according to the third law, the exponent 3 can take its position before the logarithm. And so log 10 raised to the power 3 can be expressed as 3 log 10 to the base 10 minus, now let's simplify what's in the bracket. Because 10 is multiplying 2, according to the first law, if you want to split, we have addition between the logs because the numbers are multiplying. So we have log 10 to the base 10 plus log 2 to the base 10. Now log 10 to the base 10 is log of a number to the same base, so it's 1. And log 2 from the question has been given to be 0.301. When we add 1 to 0.301, the result is 1.301. And 3 times 1 is 3. So we have 3 minus 1.301. And the answer is 1.699. 1.699. Now let's look at logarithm equation. Example: solve the following equation. Log 2x to the base 10 is equal to 1. B. Log 2x plus 80 to the base 10 is equal to 2. These are logarithm equation. That is equation involving logarithm. These are equation involving logarithm. Let's look at how best we can solve such equation. Now from A, log 2x to the base 10 equals 1. From the definition of logarithm, the base raised to the power 1 is equal to the number, that is 2x. So 2x equals 10 raised to the power 1. Now 10 raised to the power 1 equals 10. So we have 2x equals 10. Because we are solving for x, we need to divide the left hand side by 2, and that will give us x. When we divide the right hand side by 2, we have 10 over 2, and the answer is 5. Now B, given log 2x plus 80 to the base 10 equals 2. We can see that from the definition of logarithm, 10 raised to the power 2 is also equal to 2x plus 80. That means that 2x plus 80 is equal to the base, that is 10 raised to the power 2. And 10 raised to the power 2 equals 100. Now because we are solving for x, plus 80 on the left hand side becomes minus 80 on the right hand side. So we have 2x equals 100 minus 80. Where from 100, that is from 10 square. And plus 80 becomes minus 80 on the right hand side. 100 minus 80 equals 20. So we have 2x equals 20. Now we divide the left hand side by 2 and we divide the right hand side by 2. Now when we divide the left hand side by 2, we have x. And when we divide the right hand side by 2, we have 20 divided by 2. And 2 goes into 20 10 times. That means that the value of x is equal to 10. Now with this logarithm equation, after getting the value of x, you can take the value of x you are getting back into the equation and test and see whether your left hand side is equal to your right hand side. Now testing for the example in A, we had x equals 5. When you want to substitute 5 wherever we see x, 2 times 5 will give us 10. Now log 10 to the base 10 equals 1 according to the property. So you can see that x is really equal to 5. I give this to you as an exercise to test for B to see whether the left hand side will be equal to the right hand side. This is logarithm equation. Now this will bring us to an end of the presentation on logarithm.